Hello, hello, Miss Terry's here. Today we're going to learn about law of sines. Law of sines. And remember, my goal is to always make math easy. So let's begin. Okay, law of sines is used when you're solving oblique triangles. Oblique triangles, what are those? They're triangles that do not have a right triangle in them. Not right triangles. There's a standard notation of the triangle. You'll see it over there to the right. You have your angles A, B, C, and then you have your lowercase letters that are the measurements of your sides. And you are going to see those measured, in inches, feet, centimeters, etc. What they're going to do is either give you some of the measurements, and you're going to be required to find some missing sides or some missing angles. Okay, to use the law of sines, the triangle must be one of these three cases. It needs to either have two angles and one side in an AAS or an ASA format. You can see those pictures over there to the left. Or you can also use it if you know two sides and the angle opposite of one of them, which is an SSA. So three cases for the law of sines. Okay, here's the formula for the law of sines. It can be used in both acute and obtuse triangles. You can see there on your pictures the way they're drawn. Another thing to know about the law of sines is you can do them in reciprocal form. You just set them up as proportions. You can use sine A over A equals sine C over C. You can do B to C, A to C, just as long as you keep them proportionally the same. Keep your signs on top, your lowercase on the bottom, and so forth. And then you'll fill them out. You'll usually know three of these measurements, and then you'll be searching for the fourth one. Okay, let's try some. Okay, first we're going to do a triangle that's given in AAS. So what I'm going to do first is label my triangle. I like to see the picture. Makes things easier for me to solve. So I'm going to label my triangle. Okay, I know that A is 30. I know that B is 45. The side opposite of A is 32. And they want us to find the remaining angles and sides. Okay, first thing to do, first I would find the measure of angle capital C. Reason being, look in your recall button. The angles of a triangle all equal 180. So if I subtract the A and B that were already given, then I will get my C. Okay, so yay, I have one answer. Okay, now we're going to use the law of sines to find some of the other measures. And there's a 32 here. Okay, so I'm going to play off of the proportion using the A's. Reason being, the A's were given, so I'm going to use those. So I'm going to use the law of sine. So sine of 30 over lowercase, which is 32, is going to be equal to sine of 45. You see that I'm going for my B's first. This is just a basic proportion. You might remember this as the butterfly method. So basically, I will write it out for us the first time. And then from there, you'll remember it. But this is going to be sine 45 times the 32 is going to be equal to the sine of 30, b, and then if I divide by the sine of 30 on both sides, I will have my b. So you basically multiply the two that you know. We're going to times these, and then you're going to divide by that third one. So in doing so, you will get side b. Throw all that into your calculator, make sure you're in degree mode, and you will get that side b is 45.25, and this was given in centimeters. Okay, now I'm going to, so I can label this if I want to. This one over here is now 45.25. So now the only thing left to get is lowercase c. So I'm going to set up my proportion again using my a's. So sine of 30 over 32 is equal to c. And remember, we got c up top, that was 105 over c. Throw all that into your calculator, multiply sine 105 times 32. Hit equals and then divide by sine of 30. And you will get that c is equal to 61.82 centimeters. And we have identified all of our angles and our sides using a triangle AAS. Okay, next we're going to do a triangle that is an ASA. So we'll start by labeling. RB is an obtuse angle this time, 113. They gave us C was 36, and then they gave us that A was 14. And you'll see that, yes, we were given a side between two angles. I can easily get A, uppercase A. Uppercase A is a triangle. So do your 180s minus your angles, and you'll get angle A. It's equal to 31 degrees. And then from there, I'm just going to start solving. So angle A is 31. So now I have a proportion that I can use. You can't use it, you can't even solve these unless you know two. You have to know the uppercase and lowercase of at least one of these for this to work. So I'm going to start with my proportion of A. So sine of 31 over 14. We'll do B first, I guess. So sine of 113 over B, and you'll throw that all in the calculator. Sine of 113 times 14 divided by sine of 31, and you will get that that is 25.0. And this one is yards. This is the measurement of lowercase b. Okay, so now the thing we have left is lowercase c. So I'm going to use the same proportion for A, since that's the one that I already know. And then I'm going to set it up for C. So sine of C, C gave us 36. We don't know C, and you will throw that all in your calculator, and you will get that C is 16.0 yards. Okay, now we're going to do one called ambiguous case. The reason why this one's called ambiguous case is because it's the time that we're going to have the SSA. Problem with ambiguous case is a whole bunch of things can happen. Either you can have no triangle, you can have one triangle, or you could even have two triangles that happen. So this one can be a little bit confusing because you're going to have to do a little bit of work first to even see how many triangles you have. Okay, what happens when I have one triangle? Okay, so let's say that our A, and B were given. So all of these here will be given. They're going to give us these amounts. If the triangle is acute and A is equal to H, then you know that you have one triangle. Actually, you'll have a right triangle. That will happen in a right triangle. If the triangle is acute and the measure of A is greater than B, you'll have a triangle that looks like this, and you will have one triangle. If this is the case, then you will just use the methods that we were taught before, and you'll solve it out. You'll have one triangle, one answer. Okay, let's say that the triangle is obtuse. If A is greater than B, which makes sense, you can look at the A, it is definitely longer than B, then you also will have one triangle. Okay, what happens in no triangles? Again, they'll give us our A, B, and C. So how are we going to know that there's no triangle? Okay, if the triangle is acute and A is less than H, obviously you can see in this picture that if A is less than H, it won't even reach the bottom base. So obviously there's no triangle. It won't work. And if the triangle is obtuse and A is less than B, you'll see there that that won't work either. Those are not even enclosed figures. They're not triangles. So therefore, your answer would be no triangle. You can't solve it. Can't solve it. Okay, what happens when you have two triangles? You're going to see this in an acute triangle. They're again going to give you A and B, and both A's this time. Okay, if the triangle is acute and H, the height of this triangle, is smaller than A and A is smaller than B, then you will have two triangles. If you look at this triangle here, you'll see that the A was out there to the right, but we can also swing that A inside to the left of the H, and you'll notice that we have the A hasn't changed. The length of that A is still the same thing, but we have turned that into an acute triangle and an obtuse triangle. I'll give you a picture here that will show the two different triangles. So yes, if H is less than A and A is less than B, so in other words, if A and B are both greater than H, you will have two triangles. Okay, here I have what we just talked about, broke down into one chart. This might be a great screenshot to take, and keep this, lock this part of the video, because this will tell you where to go. So you look at the angle measure, you decide if you're acute or obtuse, and then from there you use your different things, and it will tell you if you have one, none, or one. Okay, so you saw me a few times refer to this H. If we don't know H, let's say that they don't give us the height, how in the world are we going to find it? Okay, let's try some, and we'll see how to find this H. Okay, so how many triangles do I have? All right, step one, we know it's obtuse, and we know that A, so we know it's obtuse, and A is greater than B. We, just by the chart that we did before, we know that this answer has one triangle. Okay, let's try another one. All right, we have again an obtuse triangle. This time, A is less than B, which means we have no triangle. Can't solve it. You actually would put no solution. You can't do this problem. It doesn't make a triangle. Okay, number 3. We know that we have an acute triangle. We have seen that our A is less than B. So A is not greater. All right, so what we're going to do is we know that it's not 1, so we can't refer to this one as like number 1. So in this case, we do have to find our H. Okay, so how in the world do we find our H? We're going to use SOHCAHTOA. And so to find the H, I'm going to give you a formula here. So you do H of sine of A times the B. And that comes from SOHCAHTOA. If you draw out your triangle, you'll actually see where this comes from. So I'm going to fill in these amounts. So H sine of 76 times 20, and I throw all that in the calculator and I get 19.41. That's not equal to A, so we know we don't have a right triangle. A is actually less than H, we have figured out, because 18 is less than 19.41. So in this case, we actually have no triangle. Can't be done. Okay, number 4. Number 4, what I'm going to do here is change the color so we don't get confused here. All right, so we have an acute triangle. I can see here that my A is greater than B, and if A is greater than B in an acute, you have one triangle. So you just solve it just like you would in the first couple examples that we did. Okay, number 5. Let's see what we got going on. We know that it is acute. A is not greater than the other side. It's actually smaller, so therefore that knocks out the one triangle. So if it knocks it out, that means we don't have a choice but to find H. So if I find H, I will get sine of 58 times my other adjacent side over there. Let's see, there we go. And that's going to give me 10.86. Okay, so our adjacent side was 12.8. Then we have a 10.6 as our H. So that's going to basically show us the situation where we have two triangles. If you're not sure about this one, you can always pause the video and rewind, and you'll see why that works. Check out the chart and look at the things, and you'll see what happened here. Okay, so how in the world do you solve them if you have two triangles? Let's try one of those. Two triangles, you already know, will be an SSA. So I am going to first fill out some stuff here. I've actually split it, but at first we're going to think of the whole thing here. So I would have 58 Over here would be 11.4. Oh goodness, that's going to be a 4. Remember that if I move this over, that same A is also right here. So it's still the same height. That would still be an 11.4. And they gave us C. So across this whole thing is 12.8. And we are tasked with finding the remaining angles and remaining sides. So first, what I'm going to do is find angle B. Angle B. So I'm going to set up my law of sines. Okay, da-da-da. I don't know my B, but I do know here. And you are fine to use the other side. You have to think about this as going the opposite. This problem is actually going the other way. Think of this one as being an ASS. So I would go through, solve all of this out, and I would get sine of B is equal to 0.9522. This is the one where you have to put it in your calculator using the inverse button, sine -1, so that you can actually get that B, and you will get that the measure of angle B is 72.21 degrees. Okay, so we have one of them. You should be able to see that that's this one, because there will be, hold on, it didn't pop up. I'll try to draw it again for you. That is your acute angle here. What you do in these, since you know that you have two triangles, I'm going to go ahead. If you remember anything about geometry and supplemental angles, you will be able to subtract from 180, and then you'll actually get your other angle. So if I do that, 180 minus the 72.21 is going to give me 107.79. And you'll see that comes from our other triangle that we are making, and you'll notice that later. Keep that number in mind because we will be using that later. That comes from our second triangle. Okay, so let's start with our C. So we now know A and B for our first triangle. So we can get C by doing that same method where you subtract from the 180. So we have 180 minus the 58 that was given, minus the 72.21 that we found, and it will give us that the measure of angle C is going to be 49.79 degrees. So you can do a little bit of, now you're ready to do the sides. Remember, we're only dealing with triangle 2. So pretty much the stuff that is to the right, we're not even dealing with that yet. We're going to do triangle 1 first. So we did find all of our angles. So I'm going to start locating some of my sides. So to get this side, using the law of sines up there, to get side C, I'm going to shortcut it a little bit because I have ran out of room. But if you set up the proportion, you'll see where all this comes from. Remember, you're multiplying the side times the angle, and then you're dividing that by the other side, and you will get that side C is 10.27. They have not given us a unit in this problem, so you can keep it like this. You know, they didn't tell us inches or feet or anything. Now, remember, you can't go, this was given so that we can solve the problem, but to find out that it was two triangles. But remember, we split it. The whole thing across was 12.8. Now we're only dealing with triangle number 1. So this part, I'll try to draw it over here for you. 2,7 is just to here. We're only dealing with triangle 1. Okay, so now let's find our other side, which is the B. And I will set that one up for you. It's going to be 11.4 sine of 72.71. And I'm going to divide that by the sine of 58. And you will get 12.84. So there we have found all of the angles only for triangle 1. This problem is not done because if you remember, we had this other issue over here, with the other B that we found. So we now have to consider that triangle. So this is half of it. Now let's do the other half. This one's triangle 2. What I did for you is draw triangle 2 a little bit bigger at the bottom. I'm going to put the problem that we had from before, so you'll see where that obtuse angle comes in. The 180 minus the 72.71, and that was 107.79, which is here. You'll see that obtuse angle right here. So we now know 2 of our angles, so I can find angle C using the property of a triangle. So 180 minus the 58 that we already know, minus the 107.79 is going to give us, this was given actually. This was given because we found it from the other slide. But here we have 14.21. And remember, the angles are in degrees. Okay, so now we have all of our angles, and we do have a side. We do know one of our sides was 11.4. Remember, all we did was just take this side over here, which was A, and rotated it here. We just moved it. It's almost like it's moving on a pendulum around this angle right here. You're just moving it over. So now that we know that about that side, we can now find, remember, this is non-existent because that's all the way across. We're now only worrying about this little piece. So we can set all these up. I'm going to start with the C using the same law of sines. Set it up as a proportion, multiply the 2 that you know, and then divide by the third one. And you will get that side C is 3.30. And then we still have to find side B. So we will set this one up 107.79. Multiply the two you know in the proportion and divide by the third one. And here you will get 12.80. So these two slides are actually the answer to that problem. You have to set this, if you have two triangles, you'll set it up and you'll do it twice. You'll say, in case 1, here is my angles inside. In case 2, here is my angles and sides. So yes, when you do have an SSA, this ambiguous case, it is a little more challenging. I hope this video helped. Thank you again for viewing, and be sure to hit subscribe so that you will always hear about some new and exciting ways that I will do my best to make math easy. You can also follow me on Twitter at Math with Dabbit, and if you ever need online tutoring, you can contact me at tntcenter.com. Thank you.